Here's a homework problem from pre-cal, and let's see how we go about solving this one. The analysis looks something like this. Since we're using the clue f is equal to g, if we equate both of the functions to each other, simplify gathering like terms, we have x squared plus x minus 8. And using quadratic formula, we should be able to find x pretty easily. Alright, let's write it up. Alright, so let's save some space over here. Let's write this up. Alright, so the solution itself, it's pretty easy. We're equating two equations. Here's the simplified one. Once we gather the terms using quadratic equation, we can solve the x. Now graphically, it's more interesting what's happening. So let's take a quick look on next slide. Alright, let's put the solution on the side, and mathematically we can see it. Now let's see what's happening graphically. This says, I think it'll give us more insight. Okay, so graphically, this is what's happening. F is in black and g of x is in red. I will mention briefly on next slide how to graph those two if you don't remember how to complete squares. But for this point, where I really want to impress you upon is a picture is worth 1,000 words. So with all this math we were trying to do, and if you can picture what's happening graphically, all the math falls into places. The 2 points we found, x equal to plus minus radical 33 over 2. Numerically, one is minus 3.37, the other one is 2.37. So here's the 2 points we found. Okay, on next slides, let's take a quick look at how to graph those one if you don't remember how to complete square, just as a brief review. Alright, so on this slide, this is a quick reminder how you find a vertex, because in order to graph a quadratic, you need to know where the vertex is at. So what I did is I copied the first two terms, and I added and subtracted this magic term so I don't change the f by itself, and then 9 is over here. The magic term comes in because I need the first three terms to be complete square, i.e. the magic number, I suppose. The way you find the magic number is take half of the coefficient, whatever in front of x, and square it. For our cases, happen to be a 1. And then you have x squared minus 2x plus 1. The three of those, if you factor it, it becomes this term. And then clean up the mess over here, and you have a positive 8. Reading the vertex then is when x equal to 1, y or fx equal to 8. So therefore, that's the vertex over here. For this one, it's a little more messier, but nothing you can't handle. What I did over here is I cleaned the coefficient of x squared first, and I pulled the 2 out. That means I lost the 2 on this one, lost 2 on this one. Since 1 I left outside the bracket, I don't have to change that. Inside, I did exactly the same thing. I added a magic number, subtracted it as not to change my g of x. The magic number is the same thing. Take whatever the coefficient in front of x, divided by 2, and I squared it. In our case, it happened to be 1 over 16. So I added a 1 over 16, subtracted a 1 over 16, thus ensuring my gx is not changing. The first three terms inside the bracket, I can complete square with that. Now, here is where most students make a mistake. Notice when you take this minus 1 over 16 outside the bracket, you do have to take care of the factor of 2. So that's why I have a minus 2 times the 1 over 16 before I combine whatever is outside the radical. Alright, so in the end, if I go ahead complete square on this one, I have 1 minus a quarter of square. This part is the quadratic, and then I have a shift up and down, which is 7/8. So our vertex over here on this curve over here is plus a quarter and 7/8, almost 1. Alright, I hope this helps. Hi, this is Dr. Pan recording from Tucson, Arizona. Please comment or share this video. Together we can make math easy again. Have a confident day.